welcome to Fundamentals of the Cascades UI framework. My name is Johan Larsby, and this is my colleague Per.
Hi, everybody. So we come from Research in Motion and work over in Sweden at the Malmö office. If you take a look on this picture to the right here, that's to the left, sorry, you're right. It's the symbol of Cascades, it's the Tat Man. So we've been using it.
So we're going to talk about Cascades today and the fundamentals of it. We do have an agenda, and this is a progress bar in Cascades. So we use that to show our progress until you get to leave and get some coffee. And first off, we're going to introduce a bit about Cascades. Then we're going to talk about the architecture of Cascades. And you see the progress bar filling up. Events is a big part of Cascades that we're going to talk about. All the different types of animations we can have. All the controls, the core controls, and the controls you can make yourself. We're gonna talk about lists, layouts, navigation. Oh, someone broke the formatting. And finally, we'll be able to drink coffee. And so let's start with the introduction about Cascades.
So what can Cascades do? I think you all have seen quite a lot of this. If you were at the keynote today, you saw some demos of Cascades applications. What it is that you get a lot of prepackaged, beautiful-looking controls that you can use to build UIs. They are all contain beautiful-looking animations, and they are easy to use. So that's a good thing.
Yeah, Cascades is a UI framework. And not only do we have the core controls, we have the ability to make your own controls quite easily. So you have freedom in both the layouting of the controls and how the look and feel of them. And we're going to talk about Cascades and Qt and why they fit together. As I told you before, the Cascades is a UI framework, but you need more when you're doing applications. You need an application framework. And we thought that the Qt was really awesome to have because it's mature, it's been around for many years, and it's been used in live products. Because it's been used a lot, it has good APIs. They removed all the bad stuff, and well, it's mature. Qt has a signals and slots mechanism to send events back and forth, and it's also a very nice feature. And there are a lot of help classes. It's almost equal to the amount you find in Java. And so Qt, what's the difference then between using what we have and just vanilla? Well, it's because we removed Qt GUI and added Cascades instead. And also one of my favorite features is the QML. It's a markup language where you can specify your UI in text. So it's very easy. It's fast to develop with, and it's fun. You have a few words to say about QML as well, I believe.
Well, I think you said it all, but I like working in QML. It's a great way to set up the UIs. And we will show you more about this in a minute.
Yeah. So this is a hello world, about the simplest thing you can do, or what we all start out with. This is how it looks. And not only can you use QML to make your UIs, if you want to go the old-fashioned way and do them in C++, you can do that as well. And this is how it would look if you made it in QMO. At first, you import the Cascades library. You add a control that is a page, which contains all the whole page that you're showing. And for the content of the page, we add another control, which is a label with the hello world text. This is pretty understandable, right? And if you want to do it in C++, it's not very hard either. We added a lot of builder classes. You see here .text hello world. So it's in the initiation of your
UI?
If you initiation of your classes, you can add all the things to it that you need, and don't have to write setter functions for everything, which is time saving. So a little bit about the architecture of Cascades.
Johan, I still think this is you that's going to talk about this.
Oh.
Yeah, you have to wait
more about
to
me.
get a drink. Yeah.
I'll just put the drink down. Sorry, it's just soda. So I wish. So what we have here is that as a foundation we have QNX, which is a 20-year-old POSIX operating system that runs on very hardcore places like nuclear plants and submarines and clocks. Well, a clock can't go wrong, right? And all that stuff is the base. And then on top of that, we add all the goodness and the platform stuff from Qt that we can use. You can, of course, go directly to the QNX APIs if you want to, but well, it's more convenient to work with the Qt stuff. And on top of that, we have our UI framework, Cascades, which utilizes both the platform APIs and the QNX stuff. And we have a lot of APIs to help you build your application, not just UI stuff. And on top of this, on top of all these amazing things, you get to be here and use all this. It's a very nice place to be. The sample applications that me and Per is developing, we're here on top of everything else. So we know how good it feels to be here.
It's good to be on top.
It's good to be on top. And another thing we find very good to be or to behave, we want to be at 60 FPS because that gives you the feeling of a solid UI. If you have 60 FPS, it's solid.
So a little bit about how does Cascades manage to achieve these high frame rates. And the Cascades engine is set up as a client-server model. So you will have a client over here, which is where the developers are. We are sitting over here, developing our application logics, setting up the UI and all these things. But the actual rendering of the UI and handling of all the events that concerns the UI is taken care of inside Cascades on the server side. So to illustrate this, let's imagine that we have an application. It's a weather application, and it uses a really complex way of calculating the weather. We have this butterfly theory that we utilize use chaos theory. So it's really heavy work to calculate all the things. We have a box of simulated butterflies in our code. Yeah, not real ones. No, that will be cruel. Oh yeah. And expensive. Yes. Yeah. Right. So what do we do with the butterflies? Oh yeah, with the butterflies, we get the number that needs to be updated in the UI. So Cascades gets an update, and even though the calculators are still running, we get a beautiful high frame rate animation of our presentation of this number that we came up with on the client side.
So another thing we're using to improve speed of the rendering is that we're using a scene graph. Scene graphs are found in 3D engines. OpenGL uses one, and by building up the UI as a tree, we can just change the relevant items. In games, you don't render things that are behind you, but so we're just using it not to render things that aren't affected. So in the Hello World example, we would have a root container, which is the top of the tree, and we'll have two children. One is the background. This is the same as this. It looks a bit dark from here, but this is mostly unaffected when we do stuff. If we do stuff on this end. So this whole part is a container that contains an image and the text, and those two are added together. And if we want to rotate and scale and change the opacity of that part of the tree, we don't do anything here. We just apply that to this end. And that way you can make changes to parts of the UI without changing all of it. We don't have to recalculate everything else. It's work well in games and work well for us. And just to show how you would do this transformation in QML, you just set these properties on the container, and it will be rendered automatically. Same thing in C++. And C, getting closer to coffee. And you want to talk some about events?
Yes, I will. Of course, you need events in order to set up a UI. You need to handle events. So when someone clicks a button or drags a slider or some other interaction with the UI, you need to somehow use events. And the way we do that in Cascades is by utilizing the Qt signals and slots. A signal, all objects in Qt, or most of objects in Qt, emit signals, and you can subscribe to these by using slots. And Cascades just maps to this way of handling events. So the first demo, can we see the screen of the phone?
Thanks, Steve. So what we're having here is a demo that does the transformation that we're showing. So when I'm touching the screen, it will change the values, and it looks like this.
So he's touching the screen now,
yeah.
Interacting with the UI. So we can go back to the presentation now. So let's have a look on how you do this in QML first up. So the way you do this is in QML is by adding a signal handler. So the container emits a touch signal, and you can listen to this by adding the onTouch signal handler to the container. And if you look on the logics here, you see that on event is down, we set the scale property of this container to 2 in both y and x direction, and we rotate it to 45 degrees. So when he pushes down, the bubble scales up and rotates. Then when you release the finger, we reset the values and it animates back into position.
And the thing about the animation is that we're going to talk about them later. I'm seeing a question. You're looking confused, saying, how can this result in an animation? And you're going to get your answer in the animation section.
In just 1 second. But you can do this in C++ as well. It works in very much the same way, but now you need to connect to the specific signal. So you have here the code for connecting to a bubble container, and you connect to the touch signal, and you set up a slot that's called touched in this case. And you declare this slot function in your header files, and you add it. And then you can do the same thing as we did in the QML. So on down, you scale up and rotate, and on up, you set it back again. So we've shown a couple of examples now where we showed you both C++ and QML for how you set up the UI components or the controls. And the thing is that in Cascades, a good thing is that you can do it in either C++ or QML. So this slider here represents that you have the option of where to write your code for the UI. So you can choose. You can choose either or.
Or both. You can combine them.
Yes. I think that's one of the points that's coming up here.
Oh.
So you're skipping ahead.
Sorry.
That's okay. There's no difference. They have the same properties, the same functionality in both C++ and QML. And as Johan just said, you can combine them. But typically what we do and what we recommend is that ones do the most of the UI in QML and the business logic on the C++ side. So handling connections to databases and setting all these things up on C++. And finally, a note on QML that it supports JavaScript for example, signal handling. So you can do a lot of UI logics in QML still. You can use JavaScript to do that. Animations.
Ooh, animations.
As promised.
Wouldn't it go back on a promise, right? So we have two types of animations. They're called explicit and implicit animations. Both of them work in a similar way, but one is automatic. That's the implicit animation. And any Cascades element can be animated. The animations run on the server thread, so you don't have to care about them. So if you remember the poor butterflies, it works like that. And we have a lot of supported animations. You can translate and set opacity and scale and move around, and even more. So you can do a lot of different animations. So the implicit animations. Thank you. Thank you. I think it's rather funny as well. We have one with explicit animations as well, but didn't make it into the presentation. So implicit animations are enabled by default. So if you change the value, if you change the opacity of an image, it will animate automatically. You don't have to do anything. It will just animate smoothly to that. And as I said, if you change a property, it will trigger that animation. And it can be turned off if you don't want it. In the beginning, when we used it, we turned it off at one occasion when we did very small increments on a property. But since then, there's been added thresholds for if it's too small an animation, we won't waste cycles on calculating that. So there's almost never a use for turning off animations, although we do have one.
Oh yeah, I have one example. We have a sample application that's called a Poem Maker. Not sure if you have seen it. Anyway, it's a very simple application. You have 3 notes of a poem that blows off the screen, and then they come back in on the screen again. And if you don't turn, the place where we turn off this implicit animation is when we do the off-screen animation. So once they are off the screen, we turn off implicit animations to get them quickly down for entering on the screen again. So that's one example where you would typically turn off implicit animations.
If you see the sample, Pal's explanation will make perfect sense. For the rest of you guys? No? No questions? Good. Well, if you want to see it, just download it from the developer site and try it. And then we have the explicit animations. Explicit animations are what we think about when we say animations, what we normally think about. It's the ones that we code ourselves, where we say, we want to move this to here and change that to this. And we can do that with a lot of features that we have. So we have easing curves that you don't have to do linear changes of values. You can ease them in many different ways. And you can set duration and repetition and a lot of other stuff that you would think would be there. So this is an example of a grouped animation. So we have two transitions that are working in sequence. So the first thing we do is rotate from 0 degrees to 90 degrees, and in a second, and then we rotate back when that animation has ended. So this is the start. This is the middle keyframe, if you will, and this is the end. And Steve, if we could have the HDMI. This is what it would look like. We sort of changed the logo for a cow. And we also added that it never stops, just so we wouldn't have to start the animation and you all had to look real close and restart it. It's just for your viewing pleasure. The samples we're showing will be available to download on the conference site, so feel free to download them. So back to the, thank you.
And so here you have, instead of a sequential animation, it's a parallel animation. So if you look on top, it says parallel. So it's two animations running together, and it's two translate transition. It's the first one is in Y direction, and if you look, you see that now there's an easing curve telling the animation what should happen at the end of the animation and the beginning. So the first one runs like this in Y direction, so something like this. And the second one has a different easing curve, and it runs in X direction, so it runs like this. But these two runs together. So let's have a look on the demo for this one. So you can switch to the screen again. So now you get this bouncing cow. Whee! All right, I think we can switch back.
So we're moving on to controls. Controls are like buttons and labels and images and lists. And we do have a whole bunch of core controls that are available in both the dark and the light theme. Most of what you saw this morning and probably in other sessions are core controls. These images are from the Cascades cookbook sample, where we try to fit everything in, but in a way that you can copy-paste the code for your own projects. As a programmer, I love places where I can find copy-pastable code. That's how I work. And I use this myself all the time. So for the introduction, we have a text label, a text input field, a slider, a button, and a longer text field. And then we have a few selections and the date time picker. So these are a few of the core controls that you can use, but you're not limited to using core controls. You can also create your own controls by combining either smaller elements and And Pal's going to talk about that, and I'm going to talk more about the core controls in extreme agile UX development with Cascades in this room at this time. So if you have nowhere else to go when you're drinking your coffee, when your coffee is finished, you could come to that session. So what about those custom controls, Pal?
Yes, Johan mentioned that you can you're not locked down by these pre-built controls. You can create your own. And sorry, just a brief introduction here. This is another sample application that we have. It's called a speed writer. It's a very simple application where you can see how quickly you type by typing this text, and then you have on top a gauge that measures the speed that you're writing. And the text controls here, they are standard controls. But the gauge here is a custom control, so that's something that we built ourselves.
How do we do that?
So how is that done? And you do that by simply putting up a small UI that you can reuse. So for the speed gauge, you will have a container where you put all the things in. So you put the background plate, a shiny glass on top, and 2 needles. And if you just put them in, it looks like this. So it's slightly misaligned. They are centered, so something has been done to it. But they also need to be moved up a little bit, and you can do that by using translation property. And then to change the dials, you expose the properties of controlling the rotation angle. And by doing this, you can change the speed on this custom control. And the nice thing about custom controls is once you built it, you can reuse it in different places in your UI. Another place where it's very usable to do this custom control or custom component is when you set up lists for list items. When you want your own special list items, you would set them up as small contained UI parts like this.
Yeah.
That brings us to lists.
Whoa, what a nice segue. A couple of years ago, I read that almost 85% of UIs in phone apps are made out of lists. So, and with that in mind, me and the colleagues, we thought we should put extra effort into making lists fast and good. So what you're seeing here is the standard list with a couple of properties set on them. So I could have added an image here and more information underneath. And this is the standard. You can also make a totally custom list items. This is from what I believe is some sort of social network. I'm not that into doing social things, so I'm not really sure where it's from. But I know that it has a header list item with sub items, and that you can add a comment to something someone said that I don't care about. Sorry, I'm just being honest here. And what we've done with the list is that we used we tested and tested and tested, and we have a visible area with all the list items rendered and shown. This is what's shown in the phone, and then we added caches before and after what's visible, and we do unloading and loading depending on which way you move. So in this case, you're scrolling downwards, and we still keep a bit of a cache here with items that we can bring in if the user decides to change scrolling direction. But we release stuff up here, and we start loading things way before they're shown. So we can do that and bring up good speed into our lists.
And by we, Johan means Cascades does this for you.
Not me.
So this is how it works behind the
Not
scenes.
us.
No,
Cascades
we are
does.
not the ones.
Yeah, that would be a hard job sitting there, just getting streamed information from your phones and saying, I wouldn't be able to be here. You can data bind a lot of stuff to the list as well. And we have a couple of prepackaged connections. So there's a SQL and XML and JSON, and we have a lot of helper classes to connect almost anything to the lists. All the special data you get from your old COBOL system that you need to have in it. You're laughing because it's true, right? And let's move over to layouts.
Oh, yeah. So when you set up a UI, you can, of course, do it by pixel perfect absolute layouting everything. So just put the elements where you want them by pixel definition. But to get a more flexible UI, it's a good idea to use these two type of layouts that you have in Cascades. It's called stack layout and dock layout. So to the left, you see a stack layout. There are cows stacked on top of each other, and to the right, you see a dock layout where you have cows docked to different positions of the screen. And you can, of course, have many of these. Now we fill up the entire screen. But when you build a UI, you use many different containers that are of different layout types. And by doing this, you get a flexible UI. So for example, if you switch to landscape, you can make it so that you change the layout, for example, and the UI will adapt to the screen. And of course, again, we have the implicit animation. So if you change the layout on your container, the objects in them will animate. And you can switch dynamically between these two. So we have a little demo of that as well. Can we switch to the phone?
Yep. Steve's way ahead of you.
Oh, yeah.
And so this is a
stack layout, I guess.
No, this is dock layout, right? This is the dock layout.
That's the dock layout.
That's the dock layout.
I'm not sure what you had there at the beginning.
I had a surprise in the beginning.
So this is a stack layout. So we have a container now with 4 different cows.
Sorry, 5 cows.
Oh, there are 5 cows, sorry. 5 different cows. Oh, there are 5 cows. I'm not sure if they are the same. And we put them into a container. And in this case, the container is of stack layout type. So they are just stacked on top of each other. But if we just change the property of the layout property of the container, what Johan does when he touches the screen here, to a dock layout, and we tell the cows how they should dock, you automatically get this switch between different layouts.
I like this one at the top that goes to the bottom.
Whee! Nice. Yep, you can switch back to the presentation.
So,
navigation. A few words on navigation. So that's all great. You have the animations, you have the controls, you have Cascades doing a lot of good things behind the scenes for you with lists. But you need to set up your entire application, so you need some way of organizing all your different screens. And you do this by using panes, and you have different kinds of panes, like pages and navigation pane and tab pane. So I have a little example down here, which is a picture application. If we start to the left, this is what you see when you start the application. It's a tabbed pane. So you can switch between the tabs and see different ways of organizing your images. And you're now in the album view. And if you press the album view in the tab pane, you use a navigation pane to navigate to the album. And when you do this, there's automatically added some Chrome down here for navigating back, and you can add extra actions down there. So now this is a list of your entire image collection. If you click an image here, then you use the navigation pane again to push another page where you can see the entire image. And then you can navigate, the user navigates back by pushing the back button, and the navigation...
Could you pick?
Oh yeah, you can pick. You can also pick back by sliding on the back button, of course. And then the panes that you have pushed to the navigation pane will be popped, and you get back to the tabbed pane. And there is a lot of more information about Cascades if you navigate to the Cascades developer microsite at developer.blackberry.com/cascades. You can also get more information by visiting the Ask the Experts roundtable. Today at 6 p.m. We'll be there, and many others.
And there's this other session with a very handsome guy later that you could attend if you want to watch him talk. I'm talking about my colleague, of course.
It's not only you one.
No. And so to summarize, we talked about the engine, the client-server setup. We talked about the way we build up and use the scene graph. And we talked about Qt and how that fits in, or how we fit in. We talked about the different types of animations we could have. We talked about custom controls and core controls. We talked about lists. We talked about cows.
Layouts.
We talked about coffee. And I'm going to flip over to the who put that there? Questions and answers. So now it's your time to ask us questions, and I'll move back to the summary to refresh your memory. So how long do we have for questions?
Well, I think we have plenty of time now, actually. We were pretty fast. It's like 20 minutes. So if you have a question, use the mic and go ahead, sir.
How did you group the animations together when you did the horizontal and vertical bounce thing? Because it looked like the previous animation you did had 2 in a row. So how did you group them together?
Yeah, let's go back to that slide. So the question was, how does one group the animations together? And we can have a quick look at the code here again, and I'll try and explain it a little bit better this time. So there you have it.
So the first one is a sequential animation. And that just,
Yeah.
Sorry.
So what you do is you put your animations in a list on the object that you want to animate. And in this case, there's only one animation. It's a sequential animation, and it contains 2 other animations. And the other case, if you go forward, is a parallel animation. So they're running together instead of in sequence. Yeah.
Sorry.
That's okay.
You can combine them and make a whole tree of them if you want to.
Next question.
Is there a way to control the speed of the implicit animation?
So controlling the speed of implicit animations, no, there is not. If you want to customize the animations, you will have to set up your own animations and turn off the implicit animations. Yep.
Did you test your type speed application compared to a traditional BlackBerry keyboard to iPhone users? Or will there a world championship of that stuff?
We haven't done that yet, but it's a great idea. Maybe we should do it, yeah.
Okay.
Yeah.
What is your experience, though?
Of typing? It has gone through some iterations, the keyboard, and now it's a lot faster. When you can use this flipping, it's really fast. The text that's in that speedwriter is really tricky, so it's oftentimes you have to type the entire word, but
okay.
I like it.
Yeah, we used one of our tech writers to write a very complicated text, and he used all his English knowledge to find weird,
very strange words.
I haven't seen them. I had to look them up in the dictionary. So we're from Sweden, so.
Yep.
So the sample you showed of the bounce animation used hard-coded X values.
Yep.
Is there going to be a way, at least from QML, to not hard-code any of those coordinates and instead just do it based on some math on the screen size?
So do you want to set up the animation properties based on the screen size?
I want to be able to set any coordinate properties of any Cascades control based on the screen size,
right,
where the actual number of the screen size is nowhere in the code.
I understand. So you don't want to hard code. If you get a different screen size, you want that number to be delivered to you, so you can just divide it by 2 or something like that.
Yeah, I don't think you want to do it on screen size, but on the container size. So that way you could change the container size, and you can ask for the width and height of that container.
There is the layout handler, I think it is.
Right, I've worked with that.
Yeah.
Thing is, I would really like it if I didn't see a single hard-coded screen size number in any Cascade samples, and last time I looked, they were full of them.
Yeah.
That might be so, yeah. There are a few where we use the absolute layout, and then we definitely need to put in. But we work as hard as we can removing those pixel
Yeah,
values.
I mean, the big problem there is it encourages people to follow that approach of building their UIs hard-coded to screen size, and you want to strangle everybody whenever they build an app that doesn't work if the screen resolution changes, but really you should be actively discouraging that with the samples.
You're absolutely right, and that's something that we really try to do, and if we have not been diligent enough, we will take another look and make sure to remove even more.
We will try to make you happy, sir. Any other questions?
So one application we'd like to be able to do is be able to detect or track pupil locations. So if you have a front view camera, is there a way to do that within this application space or domain?
You want to use the front-facing camera in your application? We have a sample for that.
Okay.
I think it was more to the question, maybe. But we have a sample applications for how to use the camera in Cascades, the photo
So
bomber.
basically I want to use a gaze or a gaze gesture approach rather than touch or anything else.
It's not something there is no built-in camera-controlled functionality into Cascades. So we haven't made anything for you to control it via face gestures or waves. You would have to implement that yourself. Any other questions? Oh, thank you. Oh, sorry. The walk of shame to the microphone.
Okay, so I'm trying to understand the content keyword or tag. In some samples, you'll see a page container or a page pane that then contains objects, buttons, other containers. And then in some code samples, there's a content keyword, : and then we start nesting other objects inside the overall containers. What does the content keyword do? What does it give you? Or is it just preference?
Yeah, so the content is a property of a pane. So like the page has a content property. And it's a default property, so you don't need to specify it. So that's why you see it sometimes and sometimes not. You're only allowed to put one control into a page. So in most cases, it will be a container. And you can either put content : or you can ignore the content, because since it's a default property, when the QML is interpreted, this will be understood as the content property tag. Yeah.
This is probably a really simple question. I just want to make sure I'm thinking about things correctly. You mentioned that there's a UI thread and then there's an engine thread that actually performs operations. When I call a C++ function from within QML, like I've referenced it and I'm calling it, is that done on the engine thread, or is that done on the UI thread when I'm calling it directly?
You want to answer this?
You go ahead, sir. You go ahead, sir.
No, engine man.
No,
Talk.
you go ahead. You go ahead, sir.
Depends on where everything that you do that affects the UI there is the client server, it talks back and forth, so it sends the messages to the server that it needs to have. And if you have functions in your in your code that you need to take care of. It will be divided by, but most of the time you send a message to a control to do something, and that doesn't affect the logic of your application. So I think you have it correct, sir.
Okay, thank you.
All right. Are we done? No? Well, maybe one more. Sure. Go ahead. What time is it? Yeah. It's okay.
When you have a callback, which thread does it actually run on? So you just got an event in, and I guess you connect it to a socket.
Yep.
And that code that's written for the socket, what thread does that run on? Is it the main application thread, or is it
It's
some thread pool?
No, it's run on the main application thread in that case.
Okay, so how do you spin off, say if you got a lot of work to do, how do you spin off something else? Do you have to manually do that yourself?
If you need to do it, you have to do it yourself. Using queues, you have queue threads.
Okay, so is it fairly simple? I'm an iOS developer,
yeah,
so...
it's fairly simple, and in most cases you don't have to do it, so...
Okay.
So I think if there's one last question, we'll take that, and I'll let you go to the promised coffee. There isn't the last question? Well, thank you all for attending.
Thank you.
And